Thank you. Thank you. So, good morning, good afternoon, good evening, good middle of the night, good whatever time it is, whatever time zone you're in. So my name is Chris, and we are going to talk about Codepush. So first of all, we're going to describe what Codepush means, what mobile distribution today looks like. We're going to try to frame the problem space with an example. We're going to describe some different technical approaches to Codepush. And finally, we're going to describe what I'm doing personally to innovate in this space. So, what is Codepush? What does this term actually mean? So I don't believe there's any authoritative industry standard definition of the term. To me, code push simply means alternative distribution. So delivering an application update to your users without using the App Store on a given platform. I'll use the term App Store broadly and interchangeably to refer either to the Google Play Store or Apple's App Store here and in the rest of this talk. I would only consider a complete application update or significant changes to significant amounts of content for some definition of significant to count as code push. I would say that things like downloading new localizations or new static images at runtime, I wouldn't consider that to be code push. There are quite a few different terms used in the community and online. So you see terms like hot update, hot code push, code push, out of band update, over the air update. I believe OTA update in particular is a term us mobile application developers have stolen at some point from telephony firmware developers. And I think they in turn co-opted it from embedded developers. I'm not sure of the precise etymology of over-the-air update, but I know that we did not invent it over in mobile land. So with that all out of the way, let's talk about mobile distribution today. What does distributing a mobile app today look like? Well, I think it looks a little something like this. So I'm not affiliated in any way with Code Magic, but I asked them if I could use this image. I asked them if I could use this image, and they said yes. And I think it perfectly captures what it feels like to build and to ship a mobile application today, right? So you build some globs of machine code, or Dalvik bytecode, or LLVM bitcode, as the case may be. You probably archive it together with some static images and some other assets. You compress it, you sign it all up, submit it off to the App Store. You wait for review, you wait for approval, you wait for rollout. This model is painful, right? There's a lot of waiting, and at the end of it, you end up with a long tail of releases, right? So just because our shiny new app release is available in a given user's market does not mean that they will actually uptake it. Doesn't mean they'll actually download it. There's very little that we can do to incentivize or to otherwise force our users to uptake the new versions that we release. And this in turn makes deprecating the backend APIs that support our apps very tricky. You need solid data about your active users and their app versions to actually make those decisions safely. Strict upgrade ordering also can't be enforced. For those users that do actually uptake our new versions, you'll find a user on version 1 of your app might upgrade straight through to version 100. So if your app has client-side data, version 100 needs to maintain all of the client-side migrations for the previous 99 versions. Otherwise, you might find a user with a bricked install from a bad migration from jumping versions. So the point I'm trying to get across here is a bit of a mess, right? So let's try to frame this with an example. So let's consider a brand new counting app startup, Prestige Counting. Say we're moving fast, we're listening to our users, we are trying desperately to find product market fit in the US market. No matter how fast our development team is iterating on the feedback from our users and releasing updates, our iteration time is only as fast as App Store review and rollout will allow for, right? Now, before I get a triumphant Twitter message from somebody talking about any of the services on the bottom of the slide here, I would say they don't apply to this scenario that I've outlined here. We have a brand new startup trying to find product market fit with our counting app, right? So things like mobile device managers, enterprise app distribution services or options, these only apply to enterprise users, right? Play Store tracks, Test Flight, Firebase, Test Fairy, services like that only apply to those users who are already enthusiastic about our offering and they're already willing to live on the edge of it. It doesn't apply to brand new users or to users who don't know about us. So let's jump our counting app startup forward quite a bit. So let's imagine our hot new counting app startup has made it. We've got millions of daily active users. We've totally captured the US market with our core offering. As a Canadian myself, our far lower temperatures and our far higher maple syrup consumption make us a bit fickler than our friends to the south. So therefore, Prestige Counting, our startup, is trialing a new multiply feature. We're testing the Canadian market with a new feature. We're also going to be doing a small trial, say, with an international airport, looking to break into B2B and enterprise space with that partner, looking for all the wonderful reliability and governance challenges that come along with that space. And wonderful isn't the right word for B2B. I lied. It is some other words though. So if we examine the feature teams at our counting app that we just described, we'll see three distinct teams. So we can see team number one is focused on maintaining and expanding our core offering, right, which is our plus feature. Team number two is focused exclusively on testing out the Canadian market with the multiply feature. And we can say that team number three is focused on our brand new division feature, as well as other tasks like hardening the security of our app, expanding handset support to include the core OEMs and handset models our airport partner deploys internally. I will admit the work of team number one does impact team number two and team number three, but I would say that team number two's work overwhelmingly is independent of team number one and two. In spite of this independence, however, the path to production for every single team is still the App Store. Right? So no matter how independent these teams are, the path to getting into users' hands is still the App Store. So what does this remind you of? What does the situation remind anybody of? No comments in the live chat. That's okay. I'll answer this for you, for everybody, or for myself at least. So to me, this reminds me of Amdahl's law, right? So to me, this appears to be a human application of Amdahl's law. So I mean, if you'd guessed Gustafson's law or the law of diminishing returns, or maybe even Conway's, if we stretch it, full points. So this is an image of Dr. Amdahl take at his home, taken in 1967, and we see he's making a very confused face. This is exactly the face that I made when I was first confronted with this exact problem. Right, so each team can move as fast as they want to, as independently as they want to, but they can only ship as fast as App Store review and rollout actually allow for through the single distribution channel that the App Store actually allows for. So everybody's on the critical path, no matter what. So how do we solve this? What do we do about this? So one approach is release trains. Gergely Oros, aka the pragmatic engineer, the author of Building Mobile Apps at Scale, among some other great books, which I have here. Great book. He conducted a Twitter poll in Q1 of this year, and he asked the Twitter mobs how often they release their apps. The most popular response was every 2 weeks. So every 2 weeks, whatever work is ready is built and included in a process leading up to being released on the App Store. This process, very broadly, is referred to as a release train. Release trains tend to look very different at every organization. At Uber, for instance, Gergely alludes to this process, including internal dog fooding of the Uber apps, wherein every employee is always using the most recent release train build of the app. At organizations whose apps are not primarily B2C like Uber, long running, think tens of hours or several days worth of automated UI integration tests or exhaustive manual testing is performed instead. And the whole point of this process is quality, right? I'm sure we've all seen this at our own organizations building mobile apps. Once that release is live, it will live forever. It is imperative that it is high quality for that reason. And this in turn can lead to a new pain point, release fever. I don't, member of the C++ ISO committee, Corentin Jabot, and I apologize if I'm butchering your name if you're listening, talking about the release cycle of new editions of the C++ language standard, coined the term release fever to describe this phenomena where changes are reduced in quality and they're rushed in order to make it on time to be included in a release. So this is absolutely something that a release train model can cause. I've seen this in organizations that I've worked with personally as well. And as we can see in this figure, our leftmost train leaves the station on time and happy. It made it on time for the release. Our train in the middle just missed the cutoff. Middle train is suffering from release fever and is also covered in hay for some reason and is very sad. Our rightmost train wasn't going to be ready for the release in the first place, and it's just right train is just happy to keep working without being rushed. So to briefly recap everything I've just ranted about here. So distribution takes a long time. Review and rollout time is measured in days to weeks. Releases live forever, right? The quality of each release is absolutely critical. And this in turn leads us into extremely long continuous integration and QA processes. And further adding to the time it takes to distribute any given change. So what we as mobile developers need is, I believe, some form of alternative distribution. How do we distribute our changes without our single point of distribution, without without the App Store? So Flutter, by its very nature, makes this extremely difficult. So Dart AOT, Dart's ahead of time compiler, is optimized to produce small executables that exhibit very fast startup, right? It favors low latency over aggregate throughput. And these are all qualities that we expect from our apps, right? That we expect them to start up fast. We expect them to reach peak performance immediately. Um, these are all qualities we expect, and this is a huge part of what makes Flutter so fantastic. Right, this is a gigantic selling point for Flutter. So I don't want to say this is bad, but it makes our scenario of alternative distribution very hard. Uh, Flutter also makes JIT release builds very hard to do out of the box. And even if you do JIT release builds, JITting is banned on iOS anyway, so it's not really a viable option. Flutter interpreter only builds are not possible. Even if they were, they would probably perform very poorly. And again, before someone on Twitter mentions this, deferred components don't count as alternative distribution. Um, Code that was not present during your initial build cannot be introduced using a deferred component in Flutter. Deferred components also can only be distributed on Android using play feature delivery. So again, we're leaving iOS behind, which I imagine for myself it's not acceptable, and I imagine for most organizations leaving iOS behind isn't acceptable. So if Flutter makes Dart AOT our only viable option for release builds, why don't we look at some different approaches that we can use to work with Dart AOT instead of fighting against it? So there are a few broad approaches that I've seen in the community at large. So we're going to go through a couple of them. So UI as configuration, embedded web content, virtual machine written in C or C++ or some other language that communicates with our Dart AOT code through FFI or platform channels or some other method, um, as well as VMs written in Dart. So we'll start off with UI as configuration. So also referred to as SDUI or server-driven UI, instead of expressing your UI as trees of widgets, you instead express your UI as trees of configuration. You could imagine this configuration could be provided to an app at runtime over the network, right? You can allow your UI to change without a new version having to be released. On the right of this slide is an example I've adapted from the documentation of a project called FAIR. And FAIR aims to enable exactly this scenario. So this snippet describes a center widget with a container and a text widget with yellow text, and it reads something to the effect of nested dynamic components. FAIR is an open source project. It's maintained by Chinese life service platform 58.com. And it works by resolving these trees of JSON into concrete objects at runtime. Resolvers are created by a FAIR compiler that integrates with Dart's build runner system. And this compiler is in turn driven through annotations in your source code. So users would annotate both their first party and the third party widgets that they would like to be able to resolve at runtime, and the compiler does the rest of the work to wire it up. FAIR, however, does not handle logic very well. So there's a small class-based DSL that allows for expressing some operations like Boolean conditionals and mapping iterables. But in general, FAIR is mostly concerned about UI. Another strong example, I think, in this category, but not open source, as far as I can find out at least, is the efforts of Chinese voucher and O2O live service platform Meituan have made. Meituan have blogged at length about the extent of their internal solution. It's along the same lines as FAIR, though they appear to have some incredibly rich static analysis that allows Meituan's compiler to produce resolvers that include AST interpreters for a large subset of Dart, as well as to produce IDE hints when developers produce annotated code that would be rejected by the compiler. Meituan also appears to have built a pretty strong observability and operations platform to monitor the performance and the behavior of their configurations when they're deployed in production. So I've given only a brief overview of two organizations that are working on SDUI and Flutter. There are a lot of people working in this space, both for Flutter itself as well as in other ecosystems, both open source and closed source. So I can't mention everybody, but there are a lot of people who are doing SDUI. So as SDUI tends to greatly constrain expressiveness of the kind of content that you can deliver, a natural next option could be embedded web content. So in an attempt to bring all of the familiar ideas and patterns of the web, as well as ideally some Turing completeness into your content, into something that could enable a code push-like experience. You might try something like the web view Flutter package. The idea is, or you take a platform web view, integrate it into the widget tree. You could even host Flutter web content in that web view. Flutter HTML package is a different approach altogether. Instead of using platform web views, provide instead an HTML and CSS rendering environment directly in Flutter. It also allows for adding extra tags, but it doesn't provide for any kind of JavaScript execution. OpenKraken is an ambitious open source project. It's backed by Alibaba, apparently already being used in production by some of Alibaba's subsidiaries like Taobao, Youku, and Tmall. OpenKraken builds up a novel browser engine on top of Skia, on top of the Flutter engine's Skia graphics implementation, all implemented in C++. And OpenKraken supports custom HTML tags implemented in Flutter, as well as support for JavaScript execution out of the box through Quick.js, with support for things like direct bytecode execution and what look like some pretty rich JavaScript method channels. So I couldn't find icons for any of these projects either. So indeed, this is clip art. So I apologize if you're from any of these, you're watching this. Couldn't find any icons for you. So OpenKraken provides a good seg into my next category here, which is JavaScript VMs. It could be argued that OpenKraken would fall into this category given how it integrates Quick.js. The only other project taking this approach that I've encountered at least is MX Flutter, and MX Flutter is backed by Tencent. MX Flutter uses either JavaScript Core on iOS or V8 on Android, and it provides bindings for a large number of Flutter classes and functions. It enables developers to write Flutter content in JavaScript and integrate it into the widget tree. We'll have a question. I'm not sure how to pronounce your name, or Lennox. What communication channel do you use to update configuration on the fly? I think it completely depends on your needs and your use case. I think HTTP is probably fine for most people. You start your app, you might do an HTTP call, figure out if there's a new update for you. I mean, WebSocket's probably fine, but I would imagine it's overkill for this kind of scenario. I think most of the complexity when we're talking about Codepush is in recoverability. So you push a bad update, now what? How do you roll back? How do you detect that on the client? How do you roll back on the client without having to publish a new app? I think most of the complexity is in caching and in rollback on the client. When it comes to actually making the connection, I think either of those are fine, depending on your needs. So thank you for the question. I do want to answer questions as I go, so don't feel like you're interrupting me, please. I want to answer as much as I can. So my last category here is JavaScript, or is VMs written in Dart. So with VMs being written in C++ or some other language, the only way to communicate with our Dart code is through FFI or platform channels. I mean, I guess you could also do shared memory, but I mean, if you hate yourself, you could do shared memory, but that doesn't sound very fun. So, FFI or platform channels are pretty much the only way. And this tends to greatly limit the richness and the performance of the interop you can achieve with those solutions, right? So having your VM be written in Dart makes interop, it really makes interop a way easier problem to solve. Though Dart has a sound reified type system that makes things really complicated. As much as having the VM written in Dart makes things easier, I would say that reified types make things hard, but not impossible. And these are examples. right? So the Dart eval package I've seen aims to provide an AST interpreter for Dart. Apollo VM similarly aims to provide an AST interpreter for Dart, but also for Java 11. Hetu, on the other side of the spectrum, is a novel scripting language. It's designed and built specifically to allow for the writing and distribution of dynamic content in Flutter. It provides a bytecode VM, a compiler, a binding generator, as well as IDE plugins. Now, these projects all appear to me to be relatively early, but I think they all have tremendous promise. Uh, so, so what about me? Why do I spend so much time in this space? Why do I know these things? Why am I talking to you? What am I doing to innovate in this space? So my passion project of the last just about 2 years ish has been HydroSDK. So HydroSDK is a tool chain, it's a virtual machine, and a runtime system written in Dart. It allows developers to author Flutter experiences in TypeScript in much the same way as we're already used to doing in Dart. It provides for things like incrementally compiling TypeScript code. It provides for hot reloading of TypeScript code in a running Flutter app. Provides function maps, which I'll admit are not quite source maps, as well as an integrated and hosted Codepush service. It is still an early MVP, I will admit. And now, in talking about approaches to alternative distribution, like we've just been doing for the last 15 or so minutes, and talking about these approaches to enable Codepush, what we're really talking about is building up a foreign execution environment and ultimately a foreign development environment, right? And these foreign environments need to be cleanly and deeply integrated into the environments that developers are already familiar with. So for us, as Flutter developers, that is Dart as a development environment, and that is Dart AOT as our runtime environment. So the last point on this slide here about binding generation and language projection. This is about building tools to produce these environments for us, given a Dart package automatically. I don't have time in this talk to also dive deep into the topic of binding generation. I've spent the last 15 months working on HydroSDK just on binding generation. And I think it deserves a dedicated talk. This is a huge topic, and I think binding generation is what distinguishes HydroSDK from everyone else in this space. If I can do some more self advertising here, I would say I want to mention that the Public Domain Publishing Company has been a fantastic, generous sponsor of HydroSDK over the last year via GitHub sponsors. So I want to give them a little shout out here. They've been fantastic, fantastic to me and fantastic to the project. So I don't see any other questions in the chat, so I'm going to stop my screen share and we're going to run through a demo of what it looks like to use HydroSDK for a simple app.
If you wish, I can ask a few questions, or we will continue to.
Yeah, definitely. Yeah.
One probably more broad question. What do you think is the this continuous release trains that's more familiar for to web developers? Like you just press refresh in your browser and bam, you have new product installed. Isn't it a little bit unusual and kind of breaks the way how mobile application works? So as a user, I prefer, probably it's only me, that my mobile application, I installed it and then I have a kind of control of the updates. For example, if I don't wish to update, I just don't update.
I think that's a valid concern from a user's perspective. Um, So I mean, my experience is overwhelmingly B2B. So most of what I talk about when I'm talking about distributing an app to a user, I'm talking about B2B. So not like your typical like social media app or rideshare or gig work app. So the users that I distribute to overwhelmingly, they're a captive audience. So they're required by their employer or they're required by the nature of their work to use the application. So for me, it's it's more important that from a distribution standpoint, I have control or my organization has control. So because you are right, it could be a valid argument from a user's perspective to say, no, actually, I downloaded version 1.2.3. I do not want 1.2.3.4.
Yeah. Okay. Okay. Yeah. Fair enough. Yeah. Probably we can continue with the live demo.
Yeah, sounds good. Can we see my VS Code?
Mm-hmm.
There
Yes.
we go. Awesome. And Georgi, I see has a question here. Is HydroSDK production ready? No, it's not. um, it is very much pre-beta. It is very early. I had a slide with resources. I failed to share that, but I will post my speaker's notes. I'm after the talk here. I'll distribute my speaker's notes on Twitter, and I'll have a fair bit of links and resources. So if you check out the GitHub for HydroSDK, you'll notice that the version number is 0.0.1, and that's for a reason. It's not production ready. It is not 1.0. You'll notice the releases are all nightlies. I think there's one alpha. I produced an alpha for an organization that was trialing it for internal use in the summer. They weren't happy with the nightly like as a word, so I said, you know what, we'll move forward. We'll start to publish some alphas. So it's pre-beta, not production ready. If you'd like to trial it, if you'd like some more support, like you can find me on Twitter. We have a Discord. My email is floating around the website. Like, please get in touch if you want to use it for real. If you want to evaluate it, please do so. But I cannot recommend that you use it in production yet. But it is definitely at a point where it works, and it's at a point where Evgeny was nice enough to let me come to Dartup and to talk about it. So if that's any indication. Any problems with app stores? Seems like stepping on their toes. So I had a really good conversation on Twitter, on a Twitter space about this yesterday afternoon actually. So I'll say this about the App Store rules. I'll say I am not a lawyer. I have read the terms for App Store Connect. I've read the terms for Google Play quite a few times. I'm not a lawyer. I can't give any definitive advice on it. From my readings of the terms, from my own experience using HydroSDK with apps I've published to the stores, from seeing and from reading about other teams that have used Codepush services like for Capacitor, using AppFlow with Capacitor.js, using App Center for Cordova, using Expo or React Native, right? There's other mobile ecosystems that have this capability and with other services. So from my own experience, as well as reading about experiences of others and other ecosystems, I'd say it's fine. I'd say a very strong fine. Uh, the reason I'll only say fine is because you cannot do things like on iOS. You can't do things like if you publish a calculator app and then you publish a code push update and your calculator app is now a first person shooter. You will get banned from the App Store, more than likely for that. You cannot completely change the purpose of your app with the code push update without being re-reviewed. You have to go through review. Likewise, Android does have some limitations around exposing operating system APIs. So, it's very vague. The wording is vague. I have never experienced anybody get in trouble for that. But they do try to prevent that exposing operating system APIs to over-the-air code on Android. The other the big limitation around the implementation of these kind of systems comes from iOS naturally. So on iOS, you cannot introduce new executable code at runtime, right? Even if you manage to sign it somehow and get it into your app, and you somehow manage to execute it, like maybe like a brand new dylib or something, you'll get banned for that. That's not allowed. That's expressly not allowed, even if you manage to figure it out. Android is far more permissive in that sense. I have heard about groups that have shipped new SOs, Elf shared objects on Android, and they can run fine apparently somehow. But on iOS, you will probably get yourself banned for that. The other thing that iOS prevents you from doing is jitting, right? So if you that's a big reason why like Flutter JIT release builds aren't suitable. You can't JIT on iOS, even if you manage to get a JIT release build. So interpreter, being an interpreter only from top to bottom is probably not going to be performant. And the only cases where you will get performance in something like that is with JavaScript. And iOS pushes you toward using JavaScript core. JavaScript core somehow is the only system on iOS that is allowed to JIT. Every other process, every other dylib on the system is not allowed to JIT. So your options are far more limited. I don't know if I answered your question there, Georgi. I talked about a lot of stuff there. Another question: is it fine to use HydroSDK and Google Play Console, Apple Store? I would just say again, it's probably not production ready. I would not encourage you to use it in production, but absolutely. Like I said, I have shipped an app at this point with HydroSDK in it. I have not got myself banned. I've worked with 2 organizations now, two businesses that have been evaluating HydroSDK for production use, despite my telling them it's not mature enough, and they seem happy so far. So I mean, I don't see any issues with what you're asking there. Okay, so
Yeah,
there's no more
probably.
questions.
Yeah, probably. Maybe we can go to the demonstration. We don't have much time, so
Yeah, sounds good.
I'm not rushing.
No worries. I don't want to. I want to respect the next speaker as well. I don't want to run into the next time slot. So I've got. We see my VS Code here. So I've got an empty folder. So we're going to just set up a new Flutter project. So Flutter create in this folder. This project's called Dart Up Demo, naturally. So there we go. So we set up our new Flutter project. I'm also within my new Flutter project. I'm going to start a npm project, because HydroSDK, the whole point is to enable us to write Flutter with TypeScript. We're going to zoom in. So we also need an npm project to enable that. So set up npm. So let's depend on HydroSDK. So we'll npm save at HydroSDK / HydroSDK, and we'll grab a nightly. What's the latest? Not latest, but the last tested for this demo. Nightly 39. We'll do nightly 396. What did I miss? What did I miss here? What? I don't know what I've done here.
Probably @ sign. No.
I probably did something weird here. Let's do this. Dependencies 396.
Yeah, install. You forgot. Yeah, install.
Oh, there we go. Thank you. I promise I rehearsed this demo. Don't worry. Okay, so we've got. So we're downloading HydroSDK for the JavaScript part of our project. So now for the Flutter portion of our project, delete Cupertino icons, we don't need that. We're going to depend on HydroSDK in the Flutter portion of our project. So we're going to grab the same version that we grabbed for npm, so also 396. Oops, and I forgot the key. So right now, HydroSDK is not publishing onto pub, so we have to depend on it through GitHub, and we can use the ref of the version that we depended on through npm and pub-get. Let pub-get do its thing. So by convention, we have, well, I mean, I guess this is enforced by the tooling. We have all of our dark code for our packages goes into lib, right? So by convention, for HydroSDK, we're going to put all of our TypeScript code into another top level folder. We're going to call it OTA, which stands for over the air. So we'll start another folder in OTA. We'll call this one lib, and within lib, we're going to start the skeleton of our counter app. So VS Code really doesn't like auto-completing a lot of these imports, so we're going to start with stateless widget, and we're going to import this from HydroSDK runtime Flutter widgets / index, the barrel file of all of the exports from widgets. Awesome. So we'll start our counter app class, and this will be a stateless widget. Give it a constructor. And then we will give it a build method. And we're also going to want, we'll start with a size box. We'll just have an empty widget. Show this off. Oops. And we're going to grab material app from material app. There we go. So in our build method, we're going to return a new material app. And we'll title it, we'll say hello from TypeScript. And we'll initial route will be / and home will give a new size box. There we go. Great. So we have a widget of a counter app, which just gives us an empty material app. So from here, we're not actually doing anything with this, right? So let's create an index.ts under the root of lib. And let's grab an import. Let's grab a run app, similar to the regular Flutter app. And we'll grab this from HydroSDK runtime Flutter run app. So what we want to do here is we're going to just call run app unguarded, right? There's no main function in TypeScript. Everything starts executing from the beginning, right? So run app will take a function and will return the counter app that we just wrote. Awesome. So how do we actually wire this all up into our Flutter app, right? Because when we run this on a device, we're going to start executing from our main.dar and our main function. So first of all, HydroSDK comes with some tools. So I'm going to clear my console. We're going to use npx to run our tools. We have a tool here called HydroC or Hydroc. So we're going to just say Hydroc run. And Hydroc is going to set up our installation. So it's going to download all of the tools that we need for HydroSDK to work in our project. So we've got things like compilers, and there's some compression stuff in here. There's all kinds of tools that we need to actually make this whole thing work. So it's going to manage that. So we asked for nightly 396 in our package.json. So the Hydroc is going to figure out what tools we need. I'm running on an Intel Mac, so here's the tools for my Mac. Some more compilers and some other tools coming down. So while that's happening, let's get our, oh no. Oh, I forgot, that's why. I forgot a project description. So the other piece here that Hydro needs to actually do anything with our code, we need to tell it how to actually run our code. So we need another file here called hydro.json. Oops. Well, by default, it's called hydro.json. You can rename this if you want. There we go. So we have to tell Hydro about our project. So we're going to call our project example project. Our project has some components in it. One of those components we're going to call, counter app. And our counter app component has some bytecode chunks in it. And one of these chunks is going to be mountable, and that's going to tell Hydro, hey, this is where you want to start executing from, and this bytecode chunk is going to give us a widget that we can mount as the base of our app. So the base URL will be OTA, because that's the folder that we made. And we're going to say, I want you to start compiling this code starting from OTA index.ts. There we go. So we have our product description. So we're building our example project with our counter app component now. And HydroSDK is going to start compiling this. So we have all kinds of dependencies that we have to build first. So it's going to figure all this out for us. So all the stuff that we've imported, so like run app and material app and all these widgets. So it's going to figure all that out for us. So in the meantime, let's go to lib and main, and we're going to blow away all of the default code in main that we were given from Flutter create. And we'll set up a main which uses run app, and we are going to run component. So run component is from, oh, Flutter didn't autocomplete that for us. There we go. So run component is from the Dart portion of HydroSDK. So we're going to ask HydroSDK to run our project, which we called example project. And the component that we're building that we named in our project file, we called it counter app. So these have to match. These have to match run component and counter app. So now we can start, we can start debugging our main.dart file. So I just hit function F5 and VS Code's going to pull up my iOS simulator for me. There's my iOS simulator. I think that looks okay on the screen share. And we'll give this a second to build and to start running. I'm just seeing the chat. NPMI, yes. that's what I was missing. Thank you, Gorgi. Okay, so our host Flutter app started up there, and there we go. We see our debug banner. So there's our material app. And so we didn't actually put any content here, right? We just have a material app with nothing in it. So let's add, how are we doing for time? Let's add to that. Let's start adding some content. So let's we'll throw a stateful widget to hold on to our counter, because we do want to make a counter app. So let's have our home page here. It's going to be a stateful widget, and we'll give it a constructor. You'll notice that we're recompiling on save. Without recompiling the whole world, we're not recompiling 206 files. We're just that we depend on. We're just recompiling this one that I'm saving. And we'll create the state class for our homepage. And we'll give this a constructor too. And these imports are missing. VS Code's not helping me. Add those imports. And we'll override dispose, and we'll override init state. And then we can give ourselves a build method and we'll put out a scaffold. Scaffold, and in our scaffold, which is not imported, in our scaffold, we want a app bar, and we're also going to want a center, column, and text. In our scaffold, we'll put through an app bar, new app bar, and we'll say the title, hello from TypeScript. And what are we missing? Oh, we need to create state, probably. That would help, wouldn't it? Yeah, that's what we're being yelled at about. Let's create state. My homepage state. There we go. Maybe. What else are we missing here? Are we missing anything? Oh, we are not actually doing anything with this widget. We still have a size box. That's probably part of the problem. My homepage instead of a size box. And there we go. So we swapped out our size box for the homepage that we just started writing with our scaffold and our app bar. So there's our hello from TypeScript. So we can change our title. Let's say hello Dartup. And we'll save that, and we'll let it recompile and hot reload. And there, our title has changed. Hello Dartup. So hot reload for TypeScript works. There are some limits to it. So I did mention Hydro isn't quite production ready. So the limitations are fairly well documented. I blogged about them quite a bit with some explanations. So if it's confusing, please reach out to me. Is this time, Evgeny?
Well, yes.
Okay, that's all good. So what I'm showing here is a tutorial on the HydroSDK website. If you go through the counter app tutorial, that's all I'm showing here live. So if you're interested, please check it out. Thanks for having me.
Thank you very much, Chris. And you can subscribe to Chris on Twitter, in his Twitter. And actually, I see there are some questions in the chat. Unfortunately, we have some time limits. So you can go to the, let me show it, to spatial chat, spatial.chat/s/dartup. And then you can go to Q&A English version and then ask your questions to Chris. Thank you very much, Chris. It was outstanding, like TypeScript, Dart, everything is mixed. I don't know what to believe right now. Thank you very much, Chris.
Yeah, the pleasure is all mine. Thank you so much for having me. I really appreciate it. I hope the viewers took something away from this. I think Codepush is important, and even if you don't like what I'm doing, if you don't like TypeScript, I mentioned there's a whole bunch of other people in this space doing really cool stuff. So if you like Codepush, find someone that's doing what you like and go help them out. There's a lot of different approaches to this.
Thank you very much, Chris, and hopefully to see you next year with the stable release.
Hopefully.
Hopefully.